All right, when we finished our last video on the y equals screen, I had put a few functions into the y equals. So if I go to y equals, there they are. Right now I have the first one active, the other ones are inactive right now. And I want to talk about two other buttons. I want to talk about window and I want to talk about zoom. The window, if I look at window settings, it tells me about the view that I'm going to see of this function. The function may be infinite in its extremes, and yet I can't look at infinity. So I must limit myself. It's a little bit like looking at through the viewfinder of a camera. How much do you want to see? Well, the first thing to fill in here is x min. Here's x min. It is the leftmost or smallest x value. X max is the largest x. Y min is the smallest y value, and y max is the largest. Now, there are also x scale. Now that tells you when you see tick marks, are they counting by ones? Are they counting by fives? What are they counting by? Y scale on the y axis, when you see the tick marks, are they counting by ones or fives or what? We will not work with the resolution or the delta x or the trace steps. We won't look at those at all. Some of your calculators don't even show those. We will look in the x direction, min and max, in the y direction, min and max. Ours is set from -10 to 10, -10 to 10. Okay, so it will have an x value of -10, an x max value of +10, a y min of -10, and a y max of +10. This is called a standard viewing window. I start with a standard viewing window very often. All right, so when I have this window and I go to graph, I see this will be -10, this will be 10, this will be -10, this is 10, and I'm seeing a graph within the window of whatever's in my y equals, which is 5x minus 12. That's in this standard viewing window. Now, it is a good window or a good view if you can see what you expect the left and right end behaviors are. This will make more sense as we look at certain kinds of functions. But if you know a function is supposed to be heading down on the left side, then you should see evidence that that's going on within your window. If there are any maxes or mins, and usually I'm talking about tops of hills and bottoms of valleys, you would need to see them. You would need to also see the intercepts, where it crosses the y-axis and where it crosses the x-axis. So let's take a look at our linear function 5x minus 12. I am in a -10 to 10 window, and I push graph, and yes, this is a line with a positive slope, so it should be rising. Okay, I see that. I know that it never tops out and it never hits the bottom. I see a x-intercept right there, and I see that there is a y-intercept, but I don't see it. It is further down. So thinking about this, you know that y min needs to be adjusted. Now, how much does it need to be adjusted? It's almost a guess. So I'll go back to window, and y min is what I need to adjust. So I'm going to use my directional arrows to go down to y min. I'm going to use the little negative sign, and I'm going to put -20. Never use the subtraction sign. In this window setting, it's the little negative sign. So now let's look at the graph. Now, I see that it is headed down this way. It's headed up here. I see the x-intercept. I see the y-intercept. I would consider this a good viewing window. Is this the only good viewing window? Not at all. I could go back to window and go back to that y-min, and maybe you only thought you needed to go down to negative 15. It is still a good view because I see the x-intercept, the y-intercept, and I see the overall behavior of the graph. Okay, so good view. You're going to have to play with it a little bit. Some people will be very aggressive. They might have done negative 50 for the y-min. I think that might have been a little bit excessive, but you still would have gotten a decent window. So you have to adjust until you see what you want. Let's go back, and I'm going to go into the y equals again, and I'm going to clear this out. I'm going to clear this one out, and I'm going to type a new one in. I'm going to type in variable x to the third power. Now, to get out of that exponent, I need to use your right arrow key to get out of it, kind of like in my math lab. Plus sign 5x squared, subtract 6x, subtract 5. Now, where did I come up with that? I just made it up. X to the third plus 5x squared minus 6x minus 5. Now, I'm going to, for the first time, say something about the zoom key. As we do different things, we'll explore the zoom key in a lot more details. Zoom box allows you to literally draw a box around a region of the graph and blow it up to that box so that that box fills the whole screen. Zoom in does just that. It zooms in, I think, by a factor of 4. Zoom out by a factor of 4. Zoom decimal, it makes it nice for something called trace, but we probably won't use it. Zoom square compensates for the fact that our viewing window is a rectangle and it adjusts so that it becomes kind of square. The one I want to spend time on today is number 6. Zoom 6 is zoom standard. Remember I said a standard viewing window was negative 10 to 10, negative 10 to 10. That literally, if I choose number 6, you can either hit a 6 or you can scroll down to 6, either way, and hit enter. Whoops, sorry, I just did the wrong zoom. Let me go back. I hit the wrong zoom button. Okay. All right, I'm just going to hit a 6. It's negative 10 to 10, negative 10 to 10. Now, if it were a little later in the semester in our course, you would know that a x cubed function, a cubic function, is down on the left, it is up on the right, and it looks a little bit like a roller coaster. And so the down on the left, I see it is going down, I see it is going up, I'm seeing the general behavior, but I am missing something up here. It is a maximum. It needs to be, there is a top to this, and then it will come back down. So I will go back to window and go down to Y max, and let's say I do 20. Let's see what it looks like. Graph. I started with a zoom standard, and it was not a great window, nor is this. I still don't see the top of this hill. So back to window, go down to Y max, and I'm going to do 40. Graph. There we go. that would be a good view. When I used a standard viewing window, -10 to 10, -10 to 10, I did not get a good view. But many times I follow the following process. I go to y equals, I type in whatever my function is that I'm going to study. I do a zoom 6. That puts it in a standard viewing window and turns the graph on. If I don't see everything I need to see, then I determine what I need to expand, in this case, Y max. I will go there. And I already know that 40 gave me a decent viewing window. Hit graph again. And there we go. So window allows me to set my X min, my X max, my Y min, my Y max. The only time I ever change scale is when I'm trying to match a graph that might be in my math lab or in a textbook. And if they show that they've used a scale of 5, then I will change mine to be a scale of 5. That's the only time I ever mess with those. We talked about zoom, but the only zoom feature that we have used so far is zoom 6. Zoom standard, which takes you -10 to 10 in the X's, -10 to 10 in the Y's. So that is it for window and zoom.